Hey guys, good morning. Thanks so much for joining this month session. And here is the GitHub link, which I already given over here. And this is the demo script, which we will be running through. So that also I just pasted it here. So we have the demo script as well as the main GitHub link, my account, okay, where all the things which I'll be working, all the demos and my personal projects, whatever I work, it will be over here. Okay, so here's my meetup group, and every month we'll do somewhere around 2 to 6 events, and this meetup link also I will paste it over here. This is the meetup link, and one final thing is the .NET Learners House YouTube channel. Please subscribe to that YouTube channel so that you'll get notified whenever there is a new video getting released. Okay, so what is that we are going to cover? I have to do a small facelift in the documentation, which I'm going to do it a little later. But as of now, I think we are ready to get going. So let's start with this. So in the previous session, let's do a quick recap of what did we do as part of the series of the SageMaker, AWS SageMaker. We did one session last, that was the first session on May 31st. June, we didn't do anything, and July, we are doing it. So we discussed about the single liners on what is this data science, machine learning, and artificial intelligence. And we have seen the picture, like how this data science, AI, ML, and AutoML, all those are getting fit in. And also, we just gave a quick introduction, 30,000 foot introduction, like what is this SageMaker? Okay, so it's a web interface where you can build, train, deploy machine learning models. And we can see that a lot of these options are there, including the CI/CD pipeline for this machine learning things, whatever we do it. And you can see this can be used by wide varieties of people. And then we had a quick introduction on the SageMaker. Okay, so we can generate this ML predictions without writing any code. Okay, so that also we have seen. We did one experiment. Now I'm going to show you again one more experiment which we'll be doing today, because the interface has changed a little bit. Interface has changed a little bit, and the functioning also changed slightly. So I saw the difference last night. So I thought, let's do that one more experiment. Okay. In that, we have seen that we have created a domain. It's already there. The same domain, we can use it, and domain and the same username, we can use it for Canvas as well as for the studio. That is, we call it as Autopilot or AutoML. We'll see that in a minute. So we'll see very quick, one simple out of the box, whatever the ready to use models which are there, and we'll start creating the data set. That's the second experiment, but the first experiment, the main focus we'll be doing on the studio. But I just want to walk you through real quick. This is common. So we have to upload the files to this S3 bucket. Okay, we have to upload that one, and you can see that there is an import button. But as of today, if I go to this data set, that import button is not available. So that's what join data, import, and create. There were three buttons, but as of today, when last night when I was trying to do create this demo script, that's where I realized that we don't have the import button. There's a slight change. Let's do that one also. To cover that, we will do one more experiment. Apart from that, I did not see any difference. The same sample also we can do, and we can do other samples also. And that was 30,000 foot, and a quick recap of what did we do as part of the previous session, where we can do analyze and out of the box, whatever the models it is there, we can use it. Now we will discuss, that was purely zero code, and whatever we are going to do now is also zero code, but I tagged something known as low code also. If you see this, no code, low code, I will show you why. Okay, I will show you that in Studio, when we create the model, so it automatically generates the Python notebooks, and it gives us an access to it. We can work on top of that. That we will do it little later. So why did we choose? I mean, we are going to create all this experiment. I created because some of the things, if you go and see it, it has taken a lot of time to complete, like an more than an hour. Okay, so you can see this 13 hours, and this is 12 hours. That means it took almost 1 hour. So that's the reason I just pre-created it, and again we'll create, but at least we'll know the rules of the game. What is that which is happening behind the scene? And why did we choose to start with this SageMaker Studio and SageMaker Canvas? Like, people who have got good enough knowledge on this max statistics and machine learning, Python, and creation of those models, reading the files and cleaning the data, and then training the model and publishing the model, testing it, publishing it, and verifying, validating whether it is creating the prediction which is very near to accurate, and then again retrain. So a lot of things has to be done. We'll come back to those things in future episodes, but right now we are starting with the no code approach. So assume that we don't know anything about machine learning. I mean, I'm a very newbie to this data analytics and machine learning. I started exploring this since past 2 months. This is the second month where I'm learning this one. So whatever I'm learning, I'm just discussing. Apologize if I do any mistake. So why did we start with these things is, as I was mentioning, that without having much of the knowledge on all those things, we can at least create some experiments and see that how is that it is generating. And whatever we did it in the previous session, if you see that now we are doing double the amount of work, whatever we did it in the previous session. So we'll do that, and then we'll again come back and we'll learn something about how is this model performing, and some of the parameters with which it specifies, like whether the model is good or do we need to further fine tune. We'll slowly get deep into the weeds, but as of now we will start with these two experiments. Okay, and if I come to, this is SageMaker. Let me go here, AWS SageMaker Studio. Let's go to the studio documentation. This one. Okay. Okay. So this is what it does. This Amazon SageMaker Studio. So it prepares the data, stores the features, and detect bias, build the notebooks. That's what I told you. No code or low code. Because we don't do anything, but it generates and it gives us. It trains the model and it fine tunes the parameters. If we can deploy and use that endpoint to predict, we'll come back in the next session. I think technically I was using the same URL twice. Yeah, I realized late in the game. Okay, and nowadays all the cloud platforms, they are doing the same thing. Every now and then the documentation will get updated. Okay, so we should be, if we are seeing a button now, so we might not see the button 30 minutes later. I'm not sure, because things are getting updated left, right, and center, because everyone is doing the faster to market. So it's good thing we are getting everything latest, fresh content. So that being said, that's the max we will discuss about this one. And getting started, let's go to this getting started documentation. And in that developers guide, let's go to this developers guide, and we'll see that use automated ML, and we'll see this little bit. We'll spend 30 seconds to 1.5 minutes, not more. We'll not, as we have seen that it does the data analysis and training, evaluation, and the deployment. We just saw that. We'll just give the raw data. For today, we'll work on the tabular data, and we'll select target, and then it automatically detects. That's one difference between the SageMaker and the Studio. And then it does the execution. It runs, and then later we can go ahead and deploy. So one thing we can discuss as of today is like regression, binary, and multi-classification. So these are some of the things which we can come and we'll discuss little deep in the next month. But at least I just want to give you one specific thing about regression. Let's assume the bike rentals are there. So any day where there is no rain or little rain, or the temperature, the sun is moderate, let's assume that there are 100 people who are coming and renting the bikes, and someday there is heavy rain and there are only 20 people, they are renting the bikes. There could be days where it is medium rain and 200 people come and buy. We don't know, but that's an exception case. But what all the parameters on which the number of bikes are getting rented? So that's like a regression. Like binary classification is whether it's going to rain today or not, like true or false, those kind of things. So we'll see that. I mean, I just want to give you one small 90,000 foot view about these two things, but we will come back later, see this, and do more of an experiment. I mean, right now, whatever we are doing is we are doing things without even knowing what it is. Okay, so at least we know that, hey, this can be done. So that's our goal. So for this, I think I have given this link. If not, again, I'll provide it here at this point of time. So we can see here there is a lot of data. Like all this data, whatever I'm using, you can get it from Kaggle. Okay, so if we go here, we'll get publicly available data sets. We can come in here, and there'll be tons and tons of data sets. What kind of data sets do you need it? Okay, like do you need it for the classification or a computer science or pre-trained. Lot of things are there. Like you see this housing price prediction. Okay, let's go and see. We'll not spend much of a time, but just at least you can see that a comprehensive data set for price forecasting with 13 key features. Okay, key features. I mean, that's a technical term. Features means like parameters or based on what the price differ. Like if in software industry, based on number of year experience, your salary should be X. Sometimes there are exceptions, but I'm telling about the regular thing, whatever is said. So based on this, we are predicting this housing price. So you can see this. These are the things which it is here. We can do the exploration also. So other information will also be there. We can go and do a deep dive, and we can see this one. I mean, some of the people, they have given the exploratory data analysis. I mean, why I came here is to show you this Python code, whatever is there behind the scenes. So we are importing the libraries, reading the content, and displaying the first few rows, and then creating the data frame, and then doing the visualization of the content, and then plotting it. Somewhere we down, they will do this heat map also. We'll see somewhere at the bottom they will generate. These are all the graphs they are generating. And where is that data encoding? Yes, regression. So this is the regression model. They created it here, and you can see that fit. That's their training this. And once they train, it generates a lot of this mean square error and mean absolute square error. We'll come back to those terms in the next session. I just want to quickly walk you through how these things will be done. Okay. Okay. Now there we have created it. Now accuracy and all these things are there. Now what is that is sometimes we will go and predict it. Okay, these all things, this is how basically we do the machine learning. We'll read the data, we might clean the data, and then we will compute all these things, and we will train the model and deploy the model. So just wanted to give you a quick overview. So without doing all those things, we'll be able to do. So the download the data set, either you can do it from the Kaggle or this link, whatever I've given. This is very good link where it has given a lot of experiments. Okay, so let's start with 2 experiments. One is the diabetic, whether someone is a diabetic or not. If we are calculating that is binary classification, like true or false, yes or no. Okay, this guy is diabetic, this guy is non-diabetic, something like that. And here in this diabetic read mission, so here what's happening is they're calculating 3 things: no, greater than 30%, and less than 30%. So it's like 3-way classification they are doing. Okay, we'll see that how the things are. Okay, so I think we spoke a lot. Now let's do this in action. So first thing what I'll do is I'll upload those files first. So I'll come in here and I'm uploading. This is the cut down version. So I'm uploading all 3 files just to showcase the time, how much it takes. Okay, so if you see that this is 3.7 MB. The more data on which you train your model, the more accurate it will generate, because it should know all the combinations. So if you train your data with lesser information, so you can expect that it might do plus or minus kind of job. It might not do the exact job, but it's a continuous improvement. Like you generate a model and you evaluate that it is giving good results, and then put it to the production. And if you see that there is some issue, again you need to retrain. It's not that end of the world. You need to come back and you need to retrain. So this one, the insurance one is 54.3, and this is 3.74. As I was mentioning, we'll do these experiments in both places, in Studio as well as in Canvas. And that's where we will see some of the differences. Okay. First, what we will do is, let's take this insurance amount. So I'll come back here, and this is the Amazon SageMaker Studio, and this is Amazon SageMaker. So inside this Amazon SageMaker, we have Studio Lab. I didn't get access. I will try for that. So Canvas. So we have RStudio and Tensor Board. So we did one session on this one. In today's session, we'll do both these experiments, see the delta. And again, we'll do one more session on these two, Studio and Canvas, where we'll go a little bit deeper. We'll see about machine learning, what is that we need to choose, which algorithm we need to choose, and how do you evaluate whether this particular model performance, how it is. And we'll see a little bit deeper. Okay. So when we did the first session, we don't know what we are doing, but we did it. And this today we'll know a little bit, we are doing it. Let's start with this AutoML. So first, let me create a experiment. Okay. So it's called as Autopilot experiment. So first thing what we will do is, we'll go ahead with this insurance and lesser data. When I compare diabetic readmission, I'll do this one. Okay. Let me copy this name so that we know what is that we're doing. That experiment name itself, we call it as diabetic readmission V1. Okay, that's the name I'm giving. Okay, that's just to identify what is that. And we have uploaded our content here. So we see that that's the 10 kilobytes, and I've selected it. Here there are rows, and let me click on select. So once I click on select, that's the first tab. So if you see that the terms target and features, and if you see in Microsoft machine learning, they call it as features and labels. So the word features is common. Some people, they call it as values, or values, I think so. Values. So different terms are being used, but net, if you see in a plain English kind of things, on what parameters this is being decided. Like if you go and eat pani puri, suddenly this guy will charge you $1 or $2 more. You say that, hey, what happened? He say that petrol and diesel prices have been hiked. So those are the parameters on which the current price of pani puri plate is being decided. So those are features. This is the target. Okay. In Microsoft machine learning terms, those are the features, and this is the label, right? So we have given the experiment name and the location, and then auto split. Okay, what is this auto split? In the previous session, when we did the Canvas, we should have split that content or the data into two pieces. One piece is to train, another piece is to evaluate. So if we give the 100% of the data to train, what is the data you will evaluate with, whether it is generating true or not? This is the historic data. So assume that we have 100 rows of historic data. What generally we will do is 80 to 90% of that historic data we will feed into train, and we'll use the 10 to 20% of the data to evaluate, to check that that what is the true value. We will give it to the model and ask it to predict, and we'll compare with the predicted versus actuals, and we'll know that what is the errors which it is coming, and based on that again we will decide whether we need to retrain this, what has to be done. And output location, I'm giving it, let it generate its output. And here the target column is the charge. Oh, this one, this is the one. Okay, readmitted, that's the target column. And weightage, select a numeric column with weight value for each data points to be used for model training and evaluation. I am not touching it. And one more thing is, if we come here, this is the experiment which is done in Canvas. We'll come back and we'll do that in Canvas also. Then we will see the difference. This one, readmission prediction. So we'll see that these are the columns which we have selected, and from these data points, some of the data points might not be important for the calculation, so we can exclude that. If you see that AC1C result, max gluco, and gender, and some of the columns which we can draw. So what is the columns which you are selecting is time in hospital, race, number, inpatient, number of times he had admitted to the hospital, and number of times he has taken to the hospital in emergency, and number of diagnostics. The rest of the things we can ignore. So just wanted to show you that before doing it. So we don't want this A1C result. And gender, it will not impact, or it might, I don't know. And max gluco, this one, we excluded that. Okay, 3, number of procedures, number of outpatient is consulting kind of thing. Number of procedures, we don't need it. Number of times he visited the hospital, we don't need that one. So we have readmitted is a target column. That means we are predicting whether this guy will come and again get admitted, or those kind of classification. Some of the experiments is like a binary classification based on few of the parameters. It will predict whether someone will be diagnosed with diabetics or diagnosed with some other like cardiovascular issues or those kind of things. It's just a prediction. So let's go to the training method. So if you know this training method, we can do that. Training method and algorithm. So I just want to let this autopilot decide. So in this deployment endpoint name, so I'll leave it as of today. We'll come back in the next session. We'll do that. So here we can go and tell that what is the kind of analysis it has to do. We are selecting the algorithm. We're saying that is it regression, like based on petrol, diesel prices, the pani puri plate price is gone, like those kind of things, regression, or the binary classification, true or false, or multi-class. So right now this is a multi-class one, but I'm leaving it to do the best job for me. So we can come and quickly review this and click on create. So once we click on create, okay, it needs 500 rows. That's cool. Okay, it needs. That's what I was telling, that we need to have enough data, because this file was having almost 69,000. So I was a little lazy to feed in, but this guy is not listening. So let's do 600 rows. Okay, that's cool. We are giving. um okay, we uh, file. Let me close. Let me close both. I'm sorry. So I'll create a copy of this. Okay. Let's call this as V2. And let's give it somewhere around 600, or okay, I think this should be good enough. I'm deleting it. Now I'm saving this. So let me minimize that. Now it is 35K. Okay, that should be decent enough. So let me go and experiment data set. So I have to come back here and upload a file, the V2 file. I didn't realize that it's going to hit me this bad, because for it to analyze, it need a lot of data. So whatever the data which I have chosen was too very low. So never mind. We'll come back here and go to the where did I upload? To the same, yeah, dev 001. Sometimes it takes time. Never mind. Anyways, we know that now we can go a little fast. So I can come back here, diabetic readmission. Diabetic readmission, whether it's going to come back. No one wants to be readmitted for the second time. Or else I'll take the bigger one. Never mind, because that's not showing up. So let's take the bigger one. So readmitted, that's the one which we want to forecast, whether this guy is going to come and get readmitted. We are excluding those columns. Outpatient, we don't need it. And one more column was there. 1, 2, 3, 4, 5. So 1, 2, 3, 4. So one column is missing. What is that column? Number of procedures. This number of procedures. Okay. So let's use this. The training method will use the same. And right now we are not going to deploy the endpoint, that we'll discuss in the next one. And here also I'm leaving it to choose the problem type, and I'm clicking on create. So the next steps are very important. So it will take a minimum of 10 to 15 minutes time to come up with this one. So behind the scene, it is executing this on a machine, and it generates this one. So let's keep it as it is over here, and then we will go ahead and redo the same experiment here. Okay, I'm just copying this one. So this is one small difference here. So what, as I was mentioning previously, we used to have import. Right now we are not having import. Directly we have to go ahead and create. So the data set is diabetic readmission. Okay, and I just click on create. And once I click on create, we need to do select uh, from which container, and what is the data which we want to take it. Let's take the bigger one. Okay, from here it is the same like what we did import. Now we will say that use the first row as header because that's the header. Readmitted, no. So more than 30% or less than 30%, those three types of classification. Now we are saying that create a data set. So now that creates a data set. So anytime you want to view that, we can come and use this one. So the data is ready. Now you can click on this. It should show the preview. So one thing I understood is maybe the underlying algorithm or program, whatever, which was showing this content right now, the old files, it's not showing that content. See, if we come back here, the previously available data sets, if I click on any of the data set, it comes and it tries to, oh, it's working. So some of the data sets, it didn't show. See this, some of the data sets, it was throwing error. I was not able to see that. I don't know why, what has changed, but we know that from where we will get this data. Here in this, we have 10 different labs. We'll get 10 different data sets. Okay, so first thing is we got the diabetic readmission, and once that is done, we'll come back to the models. Here are the defined or ready to use models. This also we can see that. We can click on predict. I can come in and I can say that I love dosa, and I love dosa, I love ice cream, 20% only. Okay, let's see that. Okay. So it's giving these kind of, I do not love dosa. So not like. So this is again part of prompt engineering. So it says that 92% negative, neutral based on this one. And this goes to the prompt engineering, like how do we do all these things. So we can come back to the model creation. So if we have shared any of the model, it will be coming here. But to share a model, we need to use the standard mode instead of the quick mode. I will show you what it is. So when we come here, so either the text analysis or image, ours is a predictive analysis. So it is again diabetic readmission. And let's see. These are the tabs which we have. So we need to do each and every step. So that's one difference. So when you compare the canvas with Autopilot, both are doing the no-code job only. But the Autopilot is taking more control and it is deciding what is best for the model creation. So this itself is, you see the shuffling and splitting of the data. generate data exploration notebook, engineering, feature engineering, and tuning your model, and then generating feature importance for the best model. And that itself is going to do all for us. So here, some of the things which we need to, this is common. We need to give the data set. So without the data set, it can't do this. Now again, we will come here. So see this, some of the options, like what is the data set, what is the target column, you want to exclude some of the columns, those things, whatever we are doing that in common. But whether the type, once you select this, you need to build it. I'll show you that in a minute. So the target column, if I come, whether the guy is readmitted or not. So if you see that the value distribution, 60% of the time it is no, 31% 30 plus, and this is 30 minus. So it's giving the column to be predicted, that information. And some of the columns which might, number of outpatient, these are things which is not that important, or it might not impact the impact the target. So those kind of values which we can ignore. And another thing is we can do the data visualization. So you can see a grid view where it shows this grid view. Okay, or we can have the column view, and we can do the data visualization. So if you want to plot any of this chart or go to the analytics and check any of those things, we can see that correlation matrix, it is here, and a lot of different things will be available. So I will minimize this tab. So we have selected the readmitted column, and here you see that standard bill, it takes 2 to 4 hours. This is a max of 15 minutes. And see that 3 plus category prediction. So it took the prediction, what type of prediction it is. So if you're not happy with this, we can come and do a numerical model, or it is 2 category, that is binary or multi-category classification. So the numeric classification was the sales forecasting, where we did we had a shipping data and address, and we combined it into the consolidated one, the previous experiment which we did it in the previous session. Now there we had to come and change it to this one. So right now it correctly predicted. If you're happy with whatever it is predicting, please keep it. If not, you need to come into advanced settings to change it. So it's a standard build. Now I want to do a quick build. Let's see. And we can preview the model here. Okay, we can preview the model, or we can come and do the quick build. Let's wait. And I'm switching between two of these things because minimum it will take 10 to 15 minutes to show the first row. Okay, so here it has created the data exploration notebook and the candidate generation notebook. We will see that in a minute. Before that, let me. Okay, it says that estimated accuracy is 61%. I don't want to hit the standard build. And another thing what we can do is we can click on the validate data. So validating this data. So it's going to, no issues have been found in your data set. Okay, if at all there is some issue, we might either need to clean or exclude those rows, because giving the gen data, the model will have some kind of issues. So let me Dataset. Let's do this one. Anyways, um we did that, and we are doing the analyze. Okay. Oh God, we have 69,000 rows in that. I didn't realize it. No problem. That should be fine. We'll take some other thing. Now come back to this, and here we will see that right now we did two trial runs, and out of these two trial runs, it is saying that this is the best model. I mean, it is trying uh, different runs, and it is generating that. And it will take somewhere around an hour to to create this. We'll keep it as it is, and let's come back and create insurance demo. Insurance demo V2. I'm calling it as V2, and let's go and select that. This is the insurance, and select the data set and split. Let's leave it, let it do the best job. And the target column is what is the charge, and age, BMI. Yes, that region, will it impact? I don't think so. We'll remove that, and then we'll use the auto, and the same thing here also, we'll leave it auto. Now let's create that experiment. So now it's doing two different experiments. One is this, the diabetic readmission, and another one is insurance. So here we can see expected build time is 45 minutes because we did a standard build. Now let's come back to the data set and use the insurance, create a tabular data set for insurance charges. I'm calling it as insurance charges. And let's upload the data from, we can do it from local. The best thing is do it from doing it from this S3 bucket, because those will be safe. And I am calling it as create dataset. It is taking some time because it should show the file as well as the columns and rows. Sometimes what happens is if there is the data type or something is wrong, as we validated the data in the previous screen, in the previous experiment, there were no issues. Suppose if there are issues, it will not recognize the number of rows or columns. And in that case, we'll not be able to see that. What is the best way to validate is when we click on that, again, it needs to come and it needs to do a top, show a top 100 version. Top 100 rows where we should be able to see that. So now what we do is we created a data set, and now I'm coming back to this one. So diabetic readmission, that's going on behind the scene. Okay, and it clearly says that 3+ category prediction. Now let's create a new model, and this we call it as insurance charges. Let's again do a predictive analysis, and this time we'll select this insurance charges, that data set, and what we have to predict is the charges. So how much the value of the prices, like wife and husband and one kid, and wife and husband with two kids, like what all the ages, whether people are smoking, those kind of things. Now, I don't think that the region will impact any of these things. So it clearly predicted that it's a numeric prediction. So sometimes it takes the other way. So here it clearly says that, hey, I have to give you a value. What is the charges? And again, you can see that the one difference I seriously see is previously when we came to this screen where it has got 60,000 plus rows were there. So it had that standard. Now it is having the quick build. Might be I would have clicked in the previous experiment. I'm not sure, but let's validate and let's do a quick build on this one. Okay, so it's analyzing. So we are doing two experiments in two different ways. One is using Canvas, one is using Studio. In Studio also specifically we are focusing on the Autopilot. Just give me a minute. I'll have a glass of water. So again, this will take some time, but we can see that it came pretty fast. And we can come and see this here, and we can get into the advanced metrics. As I was mentioning, we'll come back to these things and we will discuss that. What is this mean absolute error? What is this other things, whatever it is showing here, and the error density, we'll come back and learn about it in the next session. But as of today, let's generate this and see some of the differences like classification or the regression, whatever we are using. We'll come back and learn what it is. But as of today, we'll go ahead and we'll click on predict. And here we can predict a single prediction, or we can do a batch prediction. As I was mentioning, before training, the data we have to split it properly. That means at least historic data. Let me rephrase it. It's not data, it's historic data. Because how do we know that? Let's assume that wife and husband both are around mid-30s and they have one kid, and the insurance charges is $1,000, assume hypothetically. And once we train the model, and if we give this data, and if it is predicting 900 or 1050, that means there is some error in between. So we need to have the historic data to feed it. Once the model gets created, we have to feed the historic data. What happened really? Okay, that's the truth. So that we have to feed it and see that whether it is predicting $1,000 or whether it is predicting 950 or 1050, or is there a variation between what is actual versus what is that it's getting predicted. Now, if you see this here, if I make the age to 48, okay, you made one change and let it predict. So see this, it's the charges are 9,000. So if I make it 8 years, it is coming down. So whether the BMI or whether he is a smoker, let's see this. Let's make it 18. First see what is this price for 18. It is 3,448. Now if I say that this guy is a smoker, see that from 3,000 it went to 32,000. I don't know, but based on the smoking habit, it might impact the health of this guy. So it's bumping up the price. So let's come back to the models. Insurance one we explored at least to a decent extent. So it says that in building, it's not at build. And if you see that, one thing which we can do here is, let's go back to the models. And this model, we can share this model. Okay, that it will show when we are trying to do this. And impact of smoker on prediction is pretty high. See that? Okay, so those things are here. And let's come back and see. So for insurance also, it created one, but it didn't tag it as best because that's the only one which is available. Let's see this diabetic readmission. So it will definitely take a decent 1 hour time. So that's the reason I just pre-created those values. We can keep this running. I will close this. That will not disturb this one. It will run. So two things we can do is we can come back to experiments. We can come back to the experiments. As I was mentioning, these are the experiments which I completed yesterday. Now, if I come in here, I can go and see all these runs. But to have a decent analytics, we definitely need a 20 plus experiments. I don't have those many experiments. So I'll come in here. Let's explore a few other things. We can select any one of the model and we can see its metrics and the output artifacts and these reports and a lot of these values we can come and watch. So you can see that on what instance, okay, 18x large, on that compute instance it is running. So whatever the experiment which you are running, that's using an instance or a computing power. Okay, and what is the model, what is the data on which this got trained, and meta information also it is available. The type is processing job and a lot of other things are there. Other thing what we can do is we can come back to auto experiment. Here you can see that my first two experiments got failed because one was of huge data. It couldn't compute. Now here if you see this in Autopilot, where it shows that number of runs, trial runs, and also it shows that out of these 10, what is the best model. So we can choose that model and we can click on deploy, or we can share this model. But let's get into that model from here. So you can see some of the other things which we didn't see in the experiments tab when we went there. So here it clearly says that this is the regression type, insurance. Regression model is based on set of parameters. What is the price? And let's come back to the AutoML experiment. This is the diabetic readmission. So here the problem type is multi-class classification. So there is another thing in the diabetic prediction is whether someone will become a diabetic or not. That's true or false. That is binary classification. This is multi-class because we are generating three things: less than 30, greater than 30%, or no, he didn't join. Okay, those kind of things. And these are the parameters and features. The features, as I was mentioning, that's the technical terminology on what basis this prediction is happening. like based on the petrol and diesel prices, the food prices might go up. So the features are the petrol and diesel prices. And here, whatever we are specifying, the price of a commodity is going up based on these features. And some of the things it gives here, and you can see the performance. So the matrix table and confusion matrix, and you can see this, lot of this predicted values and actual values. So we'll come back and we'll see this one again. It's part of the performance, like how this model is performing, like what is that it predicted and what is that actual. So we'll see. And this artifacts, uh, where is this input it has come from, an algorithm or model, and it's giving other information we can see. And we can either deploy or either we can deploy or share the model. And another thing which I want to cover, let's do this real quick, is the candidate generation notebook and open data exploration notebook. Okay, this is very important. Even though we didn't write anything here, it gives more explanation on what is the problem in hand and how did it create all these things. Okay, you can go step by step, and it says that what is the kernel and what is the notebook, and it says that from where did it generate all these things. It took those values, and then you can go step by step. And this is our S3 buckets path. And if we go deep down, it says everything, whatever it has done, we will be having here as part of the programmatic, like model deployment, how it is deploying the model. And data exploration is one more thing. This is the reason I call it as a low code, even though we are not coding. There is a coding behind the scene, but it is giving us, okay, high severity, duplicate rows. There are a lot of duplicate rows in this one. And it is giving all the readmitted analysis it's giving. Okay, frequency percentage. And what was the sampling data? And duplicate rows, there were too much of duplicate rows, cross column statistics. Okay, so it gives this one, and few other things it is describing it. Feature types, okay, and the feature statistics. Features means on what parameters. Okay, so those are called features. So let's quickly recap in 2 minutes. So we tried creating the machine learning model without without using programming or much of the knowledge on the statistics or maths. So Amazon SageMaker Canvas and Amazon SageMaker Autopilot feature. That's in Studio, specifically Autopilot feature. And again, we'll come back in future about the notebooks and deployments. We'll do the endpoint deployment where we can deploy and hit it through the Postman or the Python. We'll see what is that we can do. So we did two things. So when we compare some of the things, we will be able to create it here, and some of the things which we will be able to create it here in Studio versus in the Canvas. So Studio, in particular, AutoML or Autopilot, that takes full control. We can customize and specify, but giving it full control. And we did the comparison, what kind of problem type it is taking, the same thing is being taken by the AutoML. Here we were specifying, there it assumed we selected as an auto and we left it. So it does the job. Okay. So that's it for today. So in the next session, we will again spend some more time on, we'll spend some more time on this uh, canvas as well as the studio, and learn few other things, and then we can do slowly we can move towards Python programming and do uh, this machine learning. We'll spend a lot of time on the SageMaker because we just touch the surface. I mean, only a tip we touched, a drop or something. Then again, we need to go and learn few other things, like what kind of algorithms are there, what kind of problem types are there, and how do you evaluate the model, and how do we retrain and deploy it for real-time inference and ML ops. That means CI/CD of this pipeline. We need to do a deep dive. So rest of the year we'll spend in learning machine learning and SageMaker. And thank you so much, guys. Thanks for joining. And I hope to see you guys again in the next session. Thank you.